In this video, we're going to discuss the slope of a line, what it tells us, and how to find it. So the slope of a line describes how steep a line is. I'd like to begin first by describing the difference between a positive slope and a negative slope. Let's start first with a positive slope. Let's say on some coordinate axis, we had a line that look like this. We would consider that a positive slope. And the reason is that as you move left to right, as you move in this direction along the x-axis, that the line is actually rising. So we call that a positive slope. Think of it as moving up a ramp. A negative slope, let's say we had some coordinate axis. A negative slope is going to be a line more oriented in this type of way. That's a negative slope because, again, as you move left to right along the x-axis, as you're looking at this to the left, this graph, this line is falling. Again, if you're using our ramp example, instead of going up a ramp like you would in a positive slope, in a negative slope you're going down that ramp. Another great way to think of slope is rise over run. So the easiest way to find the slope by looking at a graph is to calculate the rise over run. So let's say for each one of these graphs, we want to calculate the slope m. You'll often see m as being an abbreviation for slope. So if we want to find the slope of these lines, let's start with A. The first thing I notice about A is it is definitely a positive slope because it's rising from left to right. The other way to find the slope or to compute this rise over run is to find 2 points where it meets the coordinate axis exactly on top of that point. So if you're looking at this graph, if you notice at this point here and this point here, it's meeting the graph perfectly. Okay, so we want to compute the slope, which is rise over run. So if I want to get from this point to this point, I'm going to rise 1, 2, 3, 4 total spaces. So the rise is 4. Then I'm going to run to the right 1, 2, 3 spaces. The run would be 3. And in this case, the slope then will be 4 over 3. Rise 4, run 3. In example B, I know the slope must be negative because we're going down a ramp. We want to then look for 2 points where it meets the graph perfectly. So I would say we're meeting the graph perfectly right here at this point, and then perhaps right here at this point. So how would we get from one point to the other? Well, I could think about, I need to rise 1, 2, 3, 4, 5, 6 places. So rise 6 over, I would need to run to the left 2 places. That run to the left is actually what causes this to be a negative slope. Or you could actually think about going the opposite direction, that you would fall 6. And then run 2. That would again cause the negative slope. So we got a slope of negative 6 over 2. And we know, well, 6 divided by 2 is actually 3. This is considered a slope of negative 3. The next thing we want to discuss in this section is what we call the slope formula. The slope formula says the slope, which equals m is slope, is y2 minus y1 over x2 minus x1. And this is for points x1, comma y1, x2, comma y2. In other words, I'm just saying we have two pairs of points. So let's look at how we're going to apply this formula. Let's look at example A first. We're given the points negative 12, negative 5, and 0, negative 8. I'm going to name those points x1, y1, x2, y2. And now we're going to apply the slope formula. M equals y2 minus y1. So negative 8 minus negative 5 over x2 minus x1. 0 minus negative 12. Now we know when we subtract a negative number, we're actually really adding. Negative 8 minus negative 5 would be the same thing as negative 8 plus 5. In other words, on the top we get negative 3. On the bottom, 0 minus negative 12 would be the same thing as 0 plus 12. That's negative 3 over 12. That's a fraction that we can reduce. I would reduce that to negative 1/4. Alright, let's now try example B. Again, we're going to name these points the same way. x1, y1, x2, y2. And we're going to apply the slope formula. M equals y2, which is 12, minus y1. So 12 minus negative 18 over x2, which is 11, minus x1 is 12. As we did in the previous example, if you subtract a negative, you're really adding. So this is really 12 plus 18 would be 30. And 11 minus 12 would be negative 1. In this case, 30 is divisible by 1. So 30 divided by negative 1 tells us the slope was negative 30. Alright, last example, C. We want to find the slope for these points in C. Let's call this x1, y1, x2, y2. So what we have is y2, which is 5, minus y1 is 4, over x2 is 3, minus x1 is 3. So 5 minus 4 gives us 1, but 3 minus 3 is 0. And we should notice, can you actually divide a number by 0? You cannot, so in this case, we say that this is undefined. In this next example, we're going to look at how we use the slope to create a linear function. So let's say we wanted to graph a line where m equals negative 5 over 3. So the slope is negative 5 over 3. And we have the point negative 4, 5. In order to do this, the first thing that we want to do is put this point negative 4, 5 on our graph. Negative 4, 5 would be this point here. Since we have a negative slope, we are actually going to fall 5 and run 3. You'll see why that is actually going to create our negative slope once we do that. So I'm going to use the green just to show what's happening. From this point, we are going to fall 5. 1, 2, 3, 4, 5 places. Then we are going to run 3. 1, 2, 3. My second point should go right here. By falling 5 and running 3, you'll see that what happens is we get a line that is creating that ramp where we would be falling down that ramp instead of going up the ramp. Now we're going to look at a unique example. We're told the slope here is 5. We want to be sure to note that 5 is the same thing as 5 over 1. So we're going to rise 5 and run 1. It's very important to notice that if you just run, or if you were to just rise 5 places, you would actually be making a vertical line. We do not want to make a vertical line in this case, so we're going to recognize that's 5 over 1. And then we've got the point, -1, -4. So let's start by putting that point on the graph. -1, -4. From that point, we're then going to rise 5 and run 1. By running 1, that's going to create our positive slope. And if we connect those, we'll get a line that looks like this.